I'm James Wong, Product Marketing Manager of Linear Technology's High Frequency Product Group. This session is about designing high-performance RF. As the wireless networks migrate to fourth-generation broadband wireless and cellular technology, what enables their performance will be critically dependent on the RF components used. We have a new family of high dynamic range RF mixers designed specifically for downconverting receiver applications that are used in these 3G and 4G wireless base stations such as LTE, WCDMA, TD-SCDMA, WiMAX, and other cellular standards, as well as other radios that demand the absolute best receiver performance. In the next few minutes, I will take you through this new family of mixer performance capabilities. Then we will incorporate them into a complete receiver and illustrate how we can extract the best performance out of these mixers. The internal architecture of this family of mixer comprises a very high linearity passive double balance mixer core, combined with a high gain IF amplifier stage. The devices are built with our advanced silicon germanium process that yields excellent noise performance. The RF input has an integrated balance transformer which converts a differential to that of a 50 ohm single-ended input, so it requires no external matching circuits and it's easy to interface to. There are two selectable LO inputs designed for applications that require fast channel switching or frequency hopping. The internal LO has a buffer built in, which provides low LO input drive and high isolation. The 4-pin compatible mixers, each is optimized for performance in a specific set of frequency bands. They cover from the 700 MHz LTE, the 900 MHz GSM, to 1.7 to 2.1 GHz cellular, 2.6 GHz LTE, and 2.6 GHz and 3.5 GHz WiMAX bands. Putting it all together, each mixer has high input IP3 and a conversion gain of 7.8 dB, no loss, and very low noise figure. Aside from the dynamic range performance, this family of mixer is capable of handling very high in-band interference signals, so-called blockers, while yielding best-in-class noise figure performance. This is some 3 dB better than the nearest competing device. The benefit is that it minimizes the desensitization of receiver front end, resulting in a much more robust receiver. Powered by a single 3.3 volt supply, each mixer draws 190 milliamp supply current. Its 650 milliwatt power consumption is some 33% lower than any other device in its class. With today's base station operating 24/7, this energy saving substantially reduces the carrier's operating costs over time. It is an excellent green alternative to other comparable solutions without trading off performance. Now let's see what happens when we use one of these mixers, the LTC5540, in a complete 1.9 GHz LTE receiver. In this chain analysis, we plug in the mixer's noise figure, the gain, as well as the output IP3. In the receiver front end, we choose an LNA that has a noise figure of 0.65 dB and gain of 17 dB. It is followed by a filter and a second LNA that has an 11 dB of gain. Noise figure is less important here as the first stage LNA noise figure dominates. Finally, a high linearity IF amplifier stage having a gain of 16 dB is added to the back end. These are all real parts to give us some realizable performance. The chain analysis predicts the overall receiver will have a cascaded noise figure of 2.18 dB, which is quite good. Its overall gain is 36.4 dB. To see how good this output IP3 is, we feed a minus 30 dBm signal to the input of the receiver, which simulates a very strong signal or in-band interference. The receiver handles this large signal nicely, showing an output intermodulation product of minus 62.6 dBc, which is very respectable. At low input levels, minus 95 dBm into the receiver input, the receiver has a sensitivity or a minimum detectable signal of minus 98.8 dBm. This sensitivity is primarily limited by the 20 megahertz noise bandwidth. To illustrate, if this noise bandwidth is reduced to 5 megahertz, the receiver sensitivity would improve to minus 105 dBm. In summary, this analysis illustrates that indeed we can achieve outstanding broadband receiver performance using the LTC5540, 41, 42, or 43 family of high dynamic range mixers. For more information, please visit our website at www.linear.com. Thank you for watching.